Question 7, we got a L'Hopital's rule question. How do I know it's a L'Hopital's rule question? Because I'm asked to evaluate the limit of an indeterminate form. What is an indeterminate form? Well, the shorthand for the two most common indeterminate forms are 0 over 0 and infinity over infinity. Unfortunately, there's lots of other ones. The other ones you can algebraically transform into one of these two forms. The most common being either infinity minus infinity, or 1 raised up to the infinity, or 0 raised up to the 0 power, or infinity raised up to the 0 power. You can kind of think about these as like a struggle. You have two different parts of each expression, which are kind of working in opposite ways. Like the 0 up in the numerator wants to make this fraction really small, but the 0 down in the denominator wants to make the fraction really large. And to be clear, it's not actually a 0 in the denominator, it's a number that's approaching 0. So a really, really small number. Same idea with each of the rest of these guys. So what do we have in this specific case? Well, we can kind of do some bad math to evaluate this limit by just changing all the x's into zeros. We'd get 1 plus 0 divided by a raised up to the b divided by 0 power. Since a is a positive number, 0 divided by a positive number is just 0. 1 plus 0 is just equal to 1. b divided by 0, you might be thinking that's undefined, but really this is not b divided by 0. I guess this should be in like quotation marks or something. This 0 here represents a number that's approaching 0. Think a really, really small number. So you get b, some positive number, and you're dividing it by some really, really small number. This gets arbitrarily large. Arbitrarily large positive if this small number is positive, arbitrarily large negative if this small number is negative. Either way, we got 1 to the infinite power. We have this fourth indeterminate form. What L'Hopital's rule tells you is just that a limit of a quotient is equal to that same limit of the quotient of the derivatives if the original quotient is an indeterminate form. Or more specifically, if this is indeterminate form 1 or 2. And you're like, wait a minute, 1 or 2? How do I use L'Hopital's rule when my indeterminate form is 3, 4, 5, or 6? Well, it kind of depends. If you're in form 3, the trick will be to factor. So find something that you can pull out from each of these two terms. That'll leave you with something times something. Rewrite that multiplication as division, and it should turn into one of these two forms. We don't have this indeterminate form, so I'm not going to focus on that. We have indeterminate form 4, and what's nice about indeterminate form 4, 5, and 6 is the trick is always the same. The trick is to involve logs. What do I mean by that? Well, really what we're going to do is take the log of both sides of the equation. And you're like, wait a minute, I don't have another side of this equation. I'm just trying to evaluate this expression. Well, what we'll do is we'll give this expression a name. I usually choose the letter y. So y equals the limit as x approaches 0 of 1 plus x over a raised up to the b divided by x power. By giving this thing a name, I now have two sides of an equation, so I can take the log of both sides of the equation. Doesn't matter what log you do, but natural log is going to work out the nicest. So on the left side, I got the natural log of y. On the right side, I really have the natural log of this limit. But thanks to some limit laws, I can interchange the limit and the natural log and write the limit as x approaches 0 of the natural log of this big mess over here, 1 plus x over a raised up to the b over x power. As you may remember from a previous video, there's 3 different log rules. I'd highly recommend making sure you have all 3 of these memorized when you go into your test. The first one tells you that the log of a product is equal to the sum of those logs. The second one tells you that the log of a quotient is equal to the difference in the logs. And the third one tells you that the log of an exponential expression is equal to the product of that exponent and the log of the base. It's this third rule that comes into play here, because what I have is the log of something raised up to a power. And note that's going to be the case for any of these 3 indeterminate forms, because we have something causing these exponents to either be infinity or 0. So for all 3 of these indeterminate forms, your expression up here is going to have an exponent that contains the variable in your limit. And since your goal is to turn this into a fraction, you're trying to get rid of that exponent. How do you get rid of that exponent? Well, you use this log rule. This third log rule allows you to take this exponent and change it into multiplication. What I'm saying is I can take this exponent of b over x and bring it down in front of this natural log. That's great news because now this looks more like a fraction. You don't see it? Just rewrite this thing. Instead of b over x times the natural log of this mess, make it b times the natural log of this mess divided by x. Through some clever algebraic manipulation, I've managed to rewrite this as a quotient. And because I started out with an indeterminate form. This quotient is going to be one of these two indeterminate forms. If I change all the x's into zeros, clearly the denominators is 0. If I consider the numerator, 0 divided by a is 0, 1 plus 0 is 1, and the natural log of 1 is 0. That 0 times this b is 0. What I'm saying is that this expression is this 0 over 0 indeterminate form. That's awesome because that means I can use L'Hopital's rule. L'Hopital's rule says that this limit is the same as the limit as x approaches 0 of the derivative of this divided by the derivative of this. Got to take two derivatives. Let's start with the easy one. The derivative of x is just equal to 1. For the derivative of b times the natural log of 1 plus x over a, this b is just a coefficient, so I'll leave it alone. The derivative of natural log of x is 1 over x, so the derivative of natural log of some stuff is 1 divided by all that stuff, 1 plus x over a, times the derivative of all that stuff. That's a chain rule going on in there. What's the derivative of 1 plus x over a? Well, the derivative of the 1 is 0, and the derivative of x over a is 1 over a. You can think about this as 1 over a times x, and that 1 over a acts as a coefficient. So applying the chain rule leaves me with an extra 1 over a out here. This got kind of messy, but maybe I can clean it up a little bit. I certainly don't need to write this divided by 1 here. I can think about the b is up on the top of the fraction and the a is down on the bottom. I got b divided by this a times 1 plus x over a. L'Hopital's rule tells me that this limit is the same as this limit up here. But unlike this limit up here, where I have an indeterminate form, in other words, I can't directly determine the limit, down here I can directly determine the limit. Just informally change all the x's into zeros. If this x is a 0, I get 0 divided by a, which is just 0. 1 plus 0 is just 1. A times 1 is just a. So the whole denominator evaluates to a. The numerator is b. The limit as x approaches 0 of this expression is b divided by a. And you're like, cool, we're done. B over a is my answer. I don't see that. Right, b over a is not your answer. Look back at your string of equalities here. The natural log of y is equal to b over a. We're not trying to figure out the natural log of y. We're trying to figure out y. Right? Y is the thing that we called this limit. What we know is the natural log of y is equal to b over a. We want to solve this equation for y. How do you do that? How do you get rid of this natural log? You do e to both sides of the equation. E raised up to the natural log of y is equal to e raised up to the b over a power. When the base on your exponent and the base in your log match up, things simplify really nicely. We're left with just a y on the left side of the equation. We got y equals e raised up to the b over a power. Remembering that y is this limit is equal to e raised up to the b over a power. Come looking up at your answers here. You'll be happy to see that e raised up to the b over a power is one of our answers, answer B, which is the answer to question 7.